On numbers 3 through 8, the directions just say to find each measure, and that's what these little M's mean, is you're finding the measure. So remember, all of these answers will be in degrees, so don't forget your degree symbol as your units on each one of these answers. Some of the arcs that are asked for are given 2 letters, and then a lot of them are given 3 letters. Anytime you're given just 2 letters, you know for sure that that's a minor arc, meaning it has to be less than 180 degrees. Anytime you have 3 letters, typically that means you have a semicircle or a major arc, but sometimes you're given 3 letters just to clarify which arc you're talking about. So we'll see that that happens sometimes on these problems. So most of these are using the fact that we have central angles. Remember, a central angle is an angle whose vertex is at the center of the circle, and the relationship we learned is that a central angle and its intercepted arc are the same degree measure. So on number 3, when we're asked for the measure of arc HJ, it's asking for H to J in the shortest way possible because it's a minor arc. It's not talking about HJ from here to here. If it was H to J this way, we'd have to be given a 3rd letter on the way there, so we would know we're talking about a major arc. So minor arc, the central angle, and its arc are exactly the same degree measure, so the measure of arc HJ is 63 degrees. Don't forget your degree symbol. Number 4, we're asked for the measure of arc FGH. So typically 3 letters are saved for semicircles and major arcs, but when we look at FGH, going from F to H, going through point G, is actually another minor arc. It's just clarifying that that's the arc that we're being asked for. So I see that I have another central angle of 65 degrees, so I know the measure from F to G would also be 65 degrees. But I need to know G to H in order to answer the question for number 4 and give F to G to H. So I'm going to find this 3rd angle inside the triangle, inside the circle, given the fact that we have a line here. This diameter is a line. So I know all 3 of these angles right here have to add up to be 180 degrees. So I'm given the 65 and the 63, which I can add together and get 128. And then I can find the 3rd one by simply subtracting 128 from the 180. So this 3rd angle has to be 52. So now I have another central angle that I can use to find the arc from G to H. So G to H is also 52 degrees since we have a central angle. So now I can find the measure of the arc we're being asked for by simply adding the 65 and the 52 together and getting 117 degrees. On number 5, we're asked for the measure of arc CDE. Typically, again, that means a semicircle or a major arc, but when we look at this, we see that C to E going through point D is looks like it's a minor arc, so we'll see numerically if that ends up being the case. I see in my central angles here, I'm given a right angle symbol for this central angle. So when I look at the sides of that right angle, it goes from C to D. So I know that that arc is 90 degrees. I need to know this angle so that I know arc DE, so I can add those together to get the measure of arc CDE. I see I have a 40-degree angle over here. AFB is 40 degrees. And since these lines are intersecting at F, these angles are called vertical angles. And so remember, vertical angles are always congruent. So if this is a 40-degree angle, this over here is also a 40-degree angle. So I know arc DE is the same as its central angle. So now I can find the measure of arc CDE by simply adding 90 and 40 together and getting 130 degrees. Number 6 is asking for the measure of arc BCD. So BCD, I have part of it, the 90 degrees. I need to know B to C, so I can add that with the 90 to get the measure of the angle. Notice I always write on my figure the things I've already found, because a lot of times I can use that to help me find future answers. So now at this point, I need to find this angle, so I know that arc. And so I see that I have a line here, line B F to E, or segment BE, that all three of these angles would have to add up to 180. Or you could use these three angles adding to 180. It really doesn't matter. So you're going to need to add the 90 and the 40 together, which I already did, so I'm not sure why I'm doing that again, and then subtracting that from 180 to find that this angle right here has to be 50 degrees. 40 plus 50 plus 90 makes that 180 degree angle, and here 50 plus 90 plus 40 makes that 180 degree angle. So if this angle is 50 degrees, this arc is also 50 degrees. So now I can find BCD by adding 50 to 90 and getting 140 degrees. On number 7, we're using this circle down here. We're asked for the measure of arc LMN. Again, that's a minor arc, but just being clear about which arc we're talking about. So to find LMN, I know part of the arc, since I'm given this central angle is 30, I know M to N, that arc is also 30 degrees. So I need to know this angle, so I know this arc L to M, so I can add them together to find my answer. Again, I have a line here in Q. This segment tells me that all three of these angles have to add up to be 180 degrees. So I have 105 and 30 that I can add together to get 135, and then subtract that from 180 to get 45 degrees. So this angle is 45, since these three have to add up to get 180 for that line right here. This one right here. So if that's 45 degrees, this arc is also 45 degrees, because central angles and their arcs are the same degree measure. So now I can find the measure of arc LMN by adding 45 and 30 together and getting 75 degrees. The measure of arc LNP means going from L to P, but going through point N on the way. So we finally have our first major arc here with these three letters. So we already know L to M, M to N. Now we just need to know N to P in order to add all three of those together to get this measure. In my scenario in the angles, I can see I have another vertical pair just like I had up here with this 30-degree angle and the one that's across it. If we look at this line intersecting this line, these are our vertical angles. So this angle also has to be 30 degrees. It has to add up with the 105 and 45 to make this 180 degree straight angle. So now we can find this angle right here by knowing that all of these central angles have to add up for a full revolution of 360 degrees. So I can add up the ones that I know, the 30, the 45, the 105, and the 30 all together. Whoops, let me turn on my calculator first. So 30, 45, 105, and 30 together gives me 210, and then I can subtract that from 360 to get 150 for this angle right here, which is a central angle since its vertex is at the center, which tells me this arc is also 150 degrees. So now to find from L, N, P, I just need to add the 45 with the 30 with the 150 to get that entire measure. So we have 225 degrees for the measure of arc LNP. And the question I have here is, what if variables are involved? You have some problems on your tests that involve variables, so I just wanted to throw in another example here just to talk about that. The first thing that I noticed in this scenario are these tick marks on those arcs. Remember, tick marks show us that those are congruent. But if that is talking about length, don't forget, congruency means length of arcs are the same, are equal each other. So if these two arcs are congruent to each other, they're taking up the same amount of length around this full revolution of the circle. So if they take up the same amount of the circle, that means they're also going to have the same degree measure as well. And remember, central angles and their arcs have the same degree measure. So if this arc is congruent to this one, and this angle has a measure of 2x, that means this one's also going to have a measure of 2x. So to find the value of x, I see that these three angles together make up this line ED, or that segment I should say. So I can set up my equation by adding up these three angles, 2x plus 48, and setting it equal to 180. So combining my like terms, I get 4x plus 48 equals 180. Subtracting 48 from both sides gives me 4x equals 132, and then dividing 132 by 4 gives me x equals 33. So if that's all the question asked for was the value of x, you would be done. You could also be asked what are the measures of these angles, where you would just put 33 in for x. 2 times 33 is 66, so these are 66-degree angles, which means these arcs are 66 degrees as well. So that's just a problem involving variables that might help you on your test.